Hey everybody, for those that are on right now, just wrapping up a couple items. What are we doing on 8 people up? Hey Zach. Okay. Yeah, I'll be here going live here in a sec. Just giving everybody a chance to kind of come on board. How you guys doing? How's everybody coping? You guys hanging in there? I hope. Yeah, I mean, I don't know, most people who are struggling aren't going to, like, I don't know, admit it. Like, well, actually, not saying you guys aren't being, honest about it. I just think it's hard to necessarily admit. Okay, hang on. I'm doing one other thing. Okay, almost there. How we doing on head count? How's the head count? 13. I think we're approaching critical mass. Of course, everybody can read it, watch it later. So that's a thing. Okay, I'm just checking one other thing really quick. Yeah, okay, hang on a second. Okay, all right. Let me see. We got a few people on the Discord chat, which saves you the latency. Audio saves you the audio latency. By the way, I've been working on trying to get the audio from Discord audio to kind of kick in. It turns out that using my configuration on Mac, it's like extra pain steps to make this thing work, which I'm doing. So we'll have this thing cooked just in time for the end of the semester. So anyway, it's all new. We're figuring it out. So again, everybody on the YouTube channel, if you want to jump on Discord, you can both, you can hear it, in real time, a lot closer to real time, with the YouTube sort of video feed being on like a 20-second delay. And it also puts you in a position where you can just jump in with verbal comments if you have any of that kind of sharing and involvement. So anyway, that's kind of up to you though. Okay, so let's see. So today, what we're doing. Hang on, do I have? Hold on. I need to get just a second. I gotta get some better paper. Or you know what I can do? Hang on. I'm just gonna grab some printer paper. This is our whiteboard. That's our whiteboard today. Because we're on module 9, and we're just going to spend today on module 9. So, and you know, as a reminder, there's no homework on module 9, and there's no module exam for module 9. So when you've done all of the module exams up through 8, and then you do 10, you just get the points for 9. That's how we do this thing. I was originally going to make module 9 dependent upon giving me some kind of a design document. I might still do it. I don't know. I kind of believe in it, getting you guys to do some kind of design for the project. Okay, but that's really our topic for today, is the project. By the way, I'm experimenting a little bit with just kind of formatting on my video feed. I've got, this is actually a picture. I didn't share this with you guys. Anyway, it was a what do they call that? Cross stitch that my daughter did. She does that professionally. And anyway, one of my daughters. And I wanted to share that with you. And the rest of it's just, I don't know. I'm just toying around with OBS and video stream. And so I was talking to one of my sons, and he was just talking about, you know, that when you do that sort of the gamer stream thing, that the common way to do that is get the video feed of yourself and then, you know, fill that with other stuff. And, you know, you can put like a stock ticker, you know, up on top, and, you know, things like that. So anyway, I'm just, like I said, it's not for anything. It's just sort of sharing for whatever it's worth. Okay, so here's the deal. What I'm going to probably do, actually today, what I think I'll do is I'll leave the screen, you know, kind of mostly there. But I want to make this a little bigger just because I want to be able to draw some pictures. But I also want to, let me pull up really quick the project assignment. Hold on, there you go. Oh, let me do one other thing while I'm pulling that up. I wanted to just clarify. Yeah, so we bring that over there and make it big. Yeah. And what I can actually do, because I'm so cool, is just sort of get that a little bit more out of the way. And maybe scoochie this guy down over here. Yeah, so, okay, so I have done a bit more cleanup over in the exams. Rolling everything over to Canvas has been, you know, a level of work and a little bit of a work in progress, okay? So what you do now, here's how we do this on the Canvas exams. What we do is, if you need to take the exam, you just let me or Devin or Talmadge know. And you let us know, and we're going to turn it on for you, okay? And the idea is, what we'll basically do is turn it on for a day, for a given day. You tell us what day you want to do it. You know, like, I'm going to do it today. Or if you've done the homework, we can turn it on, you know, for another day, for example, in advance. You need to just let us know. And what we do is we open the thing up for the entire day. And you can just start anytime you want to start. There's a 2-hour window to be done. And after which it'll knock you out. And then I think the only other gotcha is it will shut you off at midnight. If you know you're going to go late, like, hey, I'm going to do it like tonight, but it might be, you know, 12:30 when I actually get to it, then just let us know, and we can either, stretch the time or just even literally open it up for a different day. Like today's the 9th, we'd be like, let's do this on the 10th. So you just let me know. And then once you start it, the clock starts. Okay, once you start the exam, we've been refining this and we've been bumping into a few problems, and some of that's just pilot error on our part, for which I apologize. But I think we're getting the kinks worked out now, so that's good. And then we're trying to keep up on the grading. And if I went through this with Alan, had just asked a question. If you have an exam that you know that you took and it shows a 0, it probably means it hasn't been graded. And again, we're trying to speed that up and get those things graded. Also, last thing about exams, the truth of the matter is that we have absolutely lost inertia. I get it. I totally get it. We've absolutely lost inertia on pace of exams. Normally, we've got 2.5 weeks left. We got today and then 2 more weeks on the regular semester. Ordinarily, this is a point in time where the testing lobby gets kind of jammed up. And we're still, a couple exams a day. And that's no bueno. And so I just wanted to give you the reminder that, you still got to get through it. I will be way more flexible on deadlines. Ordinarily, for example, we'll have stuff due, the last day of the semester. Still try, but, I'm going to be a lot more lax about that. The other thing we typically would do is have like final exam slot, and then during that slot, it's like, final time. I'm going to do this a lot more flexible. So basically, there's a point at which I have to, like when finals week officially ends, and all the way through finals week, I'll just let you keep taking exams. But you cannot procrastinate that. You can't be like, I've got like 7 more to go and I'll do them all the last day. If you take that approach, you're just going to be screwed. You're not going to survive that, okay? We're on Module 9. It's really time to be taking Module 8. And if you're way the heck behind that, you got to really kick it in the gear now. Like, okay, I plead with you, my friends. You got to get after it. You just got to get after it, okay? And the downside is we don't have the in-face. It's kind of motivating and social, down in the testing lobby. We don't have that. So that tends to make it a little harder, to just socially, you know what I mean? Okay, so everybody make me the solemn promise that you are going to kick this into gear. We're going to do everything we possibly can to, hang on a second, to help you to be successful, okay? So I'm just trying to blow that up. I seem to have lost my ability. That's not max, is it? Can't be. Come on, you dog. Being dumb. Okay, hang on. I got to do this the old-fashioned dumb way. Let's do like, what is that? Zoom in. Okay. I'm just trying to get the visibility up. That ought to do the trick. Boom, bada boom. Okay. So you guys have, yeah. Brendan gives a little solemn testimony there on the YouTube live. Trust me, the waiting approach doesn't work. There are many stories, okay? Anyway, so let's see. What else to say? Is there anything else kind of administratively that we need to hit? Anybody? Bueller? Okay. This is the large program. Now let me do Let me do the fear speech, okay? So Abby asks, which homework exams do we not need to do? Module 9 has no exam, but I think, you know what? I think I'm actually going to have you submit something. I'm going to change the Module 9 homework. I'm making a note to myself. And because during Module 9, what I try to do is talk about, you know, how to do design, how to think about design, and how to actually do some design on your project. For the homework for Module 9, what I'm going to want you to do, and I'll post it, I'm going to want you to basically just submit really informal about what you have to do, but just something that is like your design for your project. How you want the thing to work, what the structure is going to be, your state machine, whatever. It needs to be an articulation. And the reality is, if you do this, here's what happens. You're trying to learn how to code. And so a lot of times what you do when you're an experienced coder, sometimes you can just like sit down and just like start typing because you're building structure as you go, right? But when you're, you know, undergrad coders, a lot of times you're kind of like, you write your whole program and then you like sit down typing it all in. Real programmers, you know, professional programmers typically do like kind of code on the fly, right? But they're coding in an organized and structured way. They're building like empty little shells, a little routine over here that's empty, you know, but it'll go there and come back, and they'll test the overall structure. You know, I go there and I come back, and then they'll go back and now flesh it out, and then they'll test it as they go. So it's not uncommon when you're a real programmer, you know, by which I mean a professional programmer with some experience, to sort of code it up from scratch, you know, in real time. But it's usually a little bit of a bad idea for you guys to take that approach. But I'm also not a fan of write your program down and then type it all in, okay? In fact, so what do I want to say about this? I do want you to think about the structure. Sometimes you guys get in a pinch because you're sort of chasing your tail, right? On your code, trying to get the thing to work, but you don't really truly understand the fundamental underlying structure. And if you just pause and then go back and, you know, refine the fundamental underlying structure, then you find that it comes together pretty quickly. Okay, there's one other thing I just needed to grab real quick from the slides. I thought I might actually have... Let me see. Sorry, I just wanted to... I thought I had, sorry. I thought I had something ready. Apparently I don't. Okay. I'm a doof. Yeah, I just wanted to check. Yeah, darn it. Okay, no, it's all right. It's all right. Yeah, I guess I don't have it. Okay. And we did the whole assembly language thing, right? We finished all that lecture stuff. Pretty darn sure. Okay. All right. Never mind. Okay. What do we have? Couple comments. Anyway, Abby, I think that answered the question, right? homework 9 does not, or module 9 doesn't have an exam. Okay, so here's the assignment, okay? And for the large program. So first thing I want to do is put the fear back into you. We talked about the fear earlier in the semester. The fear is the way this course grade stuff is organized. It's 86% of the grade are the 12 modules, okay? And they just, whatever that is per percentage, right? 86 divided by 12, that's 8. So every module, you know, is worth 8% or whatever, and it balances out. Module 9, which we kind of started talking about the program. The program itself is worth 14% of your grade. That means you can skip it and get 86%. And from a passing grade, which is 70%, to 86%, you've got another 16% of play to be able to pass the course if you don't do the large program. Now, and by large program, I mean this thing usually winds up being about 500 or 600 lines of code. And that's essentially what that means is 500 or 600 instructions, okay? So it's not big by industrial standards, but it's big by your coding standards. A couple of caveats, okay? If you have been faking it on the homeworks, when you get into module, what is it, 6, 7, 8, you start to do more programming, 5, 6, 7, 8, I can't remember. I think it's certainly 6, 7, 8. If you're mailing that in or faking it or like looking it up online just to get the homework done, you're just screwed. You cannot do that and succeed, okay? You have to muscle through and acquire the skill, okay? You can't work on your French homework and then just look everything up online, submit it, and then think somehow that you speak French. This is about fluency, and you've got to acquire the fluency, okay? You have to acquire the fluency yourself by figuring out how to do it yourself. And looking something up and now knowing kind of how it works when somebody else does it is not the same skill, okay? The ability to read in another language is one thing, and the ability to speak in that same language is an entirely different thing. Even though they're both fluency, you understand? So I'm telling you that the programming aspects you have to take seriously. Now, I had this happen a number of times, infrequently, but enough to be notable, where a student would be they get to the exam. This happened, I don't remember which module exam, 7 or 8. And they're like, yeah, Dr. K, I left the programming ones, but there wasn't any programming in the homework, you know? And I remember the first time I was like, I haven't looked at that lately. Let me look, what? No, every one of those homeworks has programming in it. And the programming in the homeworks is similar, not identical, but similar to the the programming requirements that are in the exams. So if you don't know how to take two numbers, compare them, because you've somehow faked it, just to get through the homework, and now it's exam time, you're hosed. You will be hosed, okay? And those programs on the exams usually count, a fair amount. And so again, just saying, you've really got to spend the time and really know how to do it, okay? I will help you. The TAs will help you. Also, as a reminder, all of the instructions, the assembly instructions, there is the document, the PDF document that's up on Canvas, okay? Get this thing. I'm just going to show you again what it looks like. There are actually several, which I'll show you real quick. That one I posted, okay? That I'm not going to blow it up because, I just wanted you to show it. That's the ASCII values, ASCII codes. There's also one that I've done, for the exams. It's colorful, a little better looking aesthetically. there is this one, which is the instruction set document. Okay. And this little bad boy has, see them? There's add, there's and, all of the instructions. If you have a question about how something works, this is in the book. And if you don't have the book handy, this is just this little excerpt is on Canvas. Okay? Pretty good with that. And then the other ones that we've got, where is it? This is the pseudo ops. Okay, went a little too far. Okay, that's the pseudo ops, right? .orig, .fill, .blockw, etc., etc. They're all here. .end. That's how to use them. All that detail. These are all on Canvas. Okay, and then the last one is the interrupt services, the trap services. Okay. And so you see, I'm going to just pivot here. Let's make them a little bigger, right? That's the get C out, put S in, put SP halt, right? We haven't yet talked about this keyboard stuff, the keyboard and display monitor, okay? But that's also there. It's a very short section, but that has the documentation for the trap instructions, okay? Okay, so just to remind you that that's all out there. And let me see. All right, so Walter asks, when you were in the homework and the exam, it says to write LC3 code or instructions. Do I want it in this binary or in assembly? So Walter, can you point me to which modules? Because I think it's, if it says machine code, that's ones and zeros. If it says assembly language, that's assembly language. So I'm just pulling up real quick, just checking like what's the homework like on module 8. Homework module 8. Yeah, so let me look. I'm just looking at like module 8 as an example, because I know that's definitely assembly language. Yeah, it'll say write an LC3 assembly language program that does whatever, right? And for all of those assembly, well, that's assembly language, okay? And then if you go back to module 7, which I think we're kind of bridging the gap maybe. Module 7 will say write a short, in module 7, you're like, it says write a short LC3 program, does whatever. We are in, at the top of module 7, it says all programming exercises in this homework need to be done in LC3 machine language, not assembly language. So I'm trying to be just really, explicit about what I'm asking for. I hope that's making sense, Walter. Module 6, question 23. Let me pop over. Wait, module 6. Oh, sorry. Hang on. That's the exam. Just a second. Module 6, homework. What did Walter say? Question 23 on module 6. 23, write an LC3 program that compares two numbers and puts them into blah, blah, blah. So Walter, at the very top on that one is that same caveat. All programming exercises in this homework need to be done in machine language, not assembly language. So, all right, all good, Walter? RTFM? Okay. Let me see, Tanner, on the homework for 8, should we stick those programs in a simulator? I know what you meant. No, I would really like you to do those on the simulator so you know they work, You don't have to. You don't have to, but boy, I really recommend it. Besides the fact, look, you're coding right there. You do it, you copy it, you paste it, you know? Also way easier for us to check it. So, so Tanner, you can do it on paper. And, that's fine. But man, I would do it. I would do it. You know, I would do it with the simulator, man. Okay. All right. Any other? These are great. Great questions. So let me talk about the description of the large program, and I've got my markers. These are not dry erase. These are Sharpies, and I got my whiteboard. I got a whiteboard, and I didn't get it installed yet. But okay. So let's walk through the project, the large program. So what I want to say though is about putting the fear in you. For the love of all you hold sacred, don't borrow or look or go online or try to find how somebody else did this. I know how it's been done. And you just need to know that, the way we do all the module stuff is there's no incentive to do any plagiarizing or cheating or looking stuff up on the homework. You're really only hurting yourself. They're not graded. Then comes the exams when you're on your own. You can do it or you can't. And then comes this remaining 14%. Okay? And man, what I guess I'm saying is companies pay me as a consultant to do code review and to look at one chunk of code and to tell whether that code is derived from some other code. Okay? It is remarkably simple to tell. I know I've given part of the speech before. I did once in programming languages. They were doing like 3-line ML programs, 3 lines. And I did a clustering analysis of all the programs. And I was able, I just started doing it and I found these clusters. And I was able to basically detect a study group of 3 guys that were essentially sharing code. Okay? And I don't even think they were strictly sharing code. But my clustering analysis found the study group in the class. They were writing 3-line programs, and I could find the clustering. I could find the group. What I'm trying to say is something like this LC3 stuff. First of all, I've seen it. I know what the other solutions look like. I have all of them from past semesters and all of them that have ever been posted online. There aren't that many. And it's remarkably easy to tell when something's been derived from something else. Anyway, so is the fear filtering in here? If you really don't know what you're doing, then just don't do it. Take your lumps. It's better because if you do it and you cheat, and I'll work with you on deadlines like crazy this time, given the circumstances, okay? If you cheat on that one, then I'll just hunt you down. I mean, I will hunt you down, okay? And whatever the university's thing is, you'll flunk the class. Your university status will be jeopardized. Your major status will be jeopardized. Just don't do it, okay? Take your lumps, and I'll work with you. If you're having, medical issues, emotional issues, things coming off of all this, we'll talk about incompletes, other stuff. I will work with you as far and long and, wide as I am, like, humanly capable. But if you just, like, flat out betray that trust, it'll just go down really hard. It'll really go down hard for you. So don't do it. I don't want to hurt you, but I will if I have to. Okay? Everybody cool with that? Everybody get it? Is the fear coming in? Don't do it, okay? Grab us, work with us. I will encourage you, me, Tanner, Tanner. Who's Tanner? I saw Tanner somewhere. Tanner was the last comment. No, me, Talmadge, Devin, we will work with you. Okay? Look at your code, walk through it. We'll spend whatever time we need to try to help you. We will not allow you to like code by query, I call it. That's where you're like, what? That's the look you get. I don't know what to do. Okay, well, think about this. Okay, now what? Think about this. Now what? That's not going to wash. Okay, it's not going to wash. If you've been writing the little programs, you're going to be okay. There are only 16 opcode values and only 15 opcodes. Okay, Zach. Thank you, Zach, for acknowledging the settling of the requisite fear. Okay, let's talk about this thing. So this large program, it's meant to do a couple of things. One is just get you just writing something a little bigger. You wind up really needing to use some jump subroutine kinds of stuff. You got to use the trap instructions. You got to read from the keyboard. You got to dump messages back out, right? Okay, thanks, Devin. Appreciate you being scared. And it just requires that you do a lot of things that bring all the pieces together. Okay, that's kind of a big one. And the other thing it does is it kind of sets you up where you can't just get by with PC offset stuff. You can't just be jumping around PC offset. It's going to get big enough that you have to use the base registers, to go bigger distances. Okay. If you grow the thing short and small, and make it bigger over time, there's a point at which it like gets to a certain amount of big and then it's going to break. So I'm telling you right now that you need to be thinking about that design. So this is why I want you to do that thing I'm going to post for homework 9. Okay. It's going to be, the homework 9 is not going to be like graded real rigorously. Okay. I just want you to go through the exercise. This is to aid you and help you along to do the project. So also, if you're not going to do the program, and you don't do the homework 9, you don't get the points for it, just for doing the exams. But thinking about the program is still a value. I think there's still an advantage to that. So let me see, what else? Yeah, so I want you got to start thinking of this thing structurally, okay? So here's the thing. We start off, it says one of the things an assembler has to do is take assembly language instructions, right? Like add and jump and convert those to opcodes, right? You know that somebody's doing that. Who's doing it? Each assembly instruction has a corresponding 4-bit binary opcode. You know that. For example, add is 0001, and is 0101, etc. You know all that, okay? What we're basically doing is having you do the very first rudimentary step of writing your own assembler. And you're going to do it in assembly, okay? Most of the time you'll write these things in higher level languages, C, C++, C#, things like that. So you're going to write an LC3 program, and here's what it's going to do, okay? Number 1, you spit a message to the screen. It can be whatever you want it to say. That after which the user types in an instruction, and it's going to ask them to write it, to enter an instruction. The user is going to type their instruction and press enter, okay? That's the very first thing. You're going to take that string that they input. Now you can do this a couple different ways. You could take every character they type as they type it. Like they type the A and you type and you see the A and you move to some state. They type the D, you move to a state. Or you can let them enter it all into memory, then set up a pointer and start like parsing the string in memory. You can do it either way, okay? But so if the instruction that the user types is a legal LC3, assembly language instruction, then you display the opcode. So if they type add, you print out 0001. Okay, that's it. If it's not legal, like they type ADDD or Andy or, you know, something, instead of and, they type Andy, then you display an appropriate error message. And you can get as fancy or simple as you want, you know? It's really cool if you can say something like, Andy is not a legal instruction, you know, etc. Now, what does it mean to be a legal instruction? Let's get back to it. After you're done with your output, either spitting out the opcode or an error message, you just loop back to the top, you reinitialize, and you go again. That way you can test it over and over and over again. And then when they type quit, okay, then you're done. Then you stop. Okay. It has to be non-case sensitive. So if they type lowercase add, uppercase add, mixed case, it doesn't matter, okay? So we got to talk a little bit about what are you going to do about that, right? How are you going to do that? And then this is the other one. As the user types instructions, your program needs to echo what they type. Remember, we talked a little bit about this, I think, last time. The fact that when you enter characters from the keyboard, they're not, by default, they're not printed to the monitor at the same time. So you got to be like, as I'm typing, it's echoing, which means you've got to read it, and then you've got to also turn around and write it out, okay, to the monitor. Let's talk about case insensitivity. What are you going to do? I'm going to pause for a minute. What are you going to do to handle case insensitivity? You can either go audio chat on the audio channel on Discord. You can text chat on Discord. So tired. Or you can text chat on YouTube. Either way is fine. And this is a back massager, and I am in pain. So I'm dropping this thing in right now. You wish you had this. Yeah, this is going to get me through. It's like there's something about my chair, which is a great chair, but something about the position I naturally try to get in for the video broadcast. And it just, like, I don't know, my back just gets so sore, and I'm old. So I'm just killing time, waiting for your comments. What have we got? The question is, how are you dealing with the case insensitivity, right? What do you do? Anybody? I'm waiting. Can you hear the back massager? It's not like super loud, but I'm just curious if that's any interference with the audio. Come on, everybody, where are you? Oh, insufficient. So, insufficient sleep is what I was trying to say. So, Abby asked, is it possible to set all answers to a certain case? What do you mean by that? That's not super precise. Vlad, everything coming in is ASCII, so you're definitely going to be manipulating the ASCII. Zach says, add or subtract the difference between uppercase and lowercase characters. More precision, Zach, on that? I mean, sure, right? All of those, the YouTube comments. Yeah, and so Walter says, look for ASCII values in a specific range. Yeah. What else, though? But here's the thing. There's how are you going to deal with the fundamental struggle? I'm going to type in, I might type a lowercase, I'm going to say and. I might type a lowercase a, or I might type an uppercase a. You see what I mean? And both of those have to be okay, right? So what are you going to do precisely? What's the algorithm? I mean, how are you going, you've really got two basic ways you can go with this thing. I want you to just try to articulate it. So James suggested, that's James, right? Some kind of like dot lower method. Yeah, right. That's the idea that it's like every time they type something, you basically make it lowercase so that when you're done, or uppercase, right? It doesn't matter. But you basically like make the thing, right. So whoever Jess Larvis is, you convert all the lowercase values to uppercase or vice versa. Then all the comparison strings that you're comparing it to need to be that case. So if you can make everything lowercase, then what you're comparing to has to be lowercase. Or if you're making everything uppercase, then what you compare to has to be uppercase. Right? That's a great approach. I think that's probably the right approach. Zach, one of the Zachs, says you can put every different case situation possible for every instruction in memory. Okay? So that's an interesting approach. Now, anding it with the input, it depends on what you mean by that, Zach. Anding it with the input, because if I type input and I and it with something and they match, it's just going to be the input again, right? If I wanted to try to create and also I've got to do that like word by word. You still got to do that one thing at a time and kind of compare them to be equal. Well, how do we compare things in LC3 assembly, right? How do you compare things to be equal? You take one, you negate it, and then you add them together, and if it's 0, they were equal. So that is, in fact, how you can do, certain kinds of string compares. But you got to do it a character at a time. Let me see. We had a couple of other comments coming through on the chat. Right. So, oh, is that, okay, that was Vlad? Okay. So Vlad's like, convert all the lowercase to uppercase before trying to interpret. Yes. And then Zach said, wait, what if you subtracted the entered string from the expected string? And if it was a multiple of the difference between the difference, that is not clear at all, man. I'm sorry, Zach. You gotta run that again, okay? And then what Walter was talking about, actually, so I still don't know who Jess Larvis is. I think Vlad was actually pointing at Walter's comment. That if it's lower, then the definition of lowercase in ASCII is that it is in a value from, that's decimal, right, Walter? That's 95 to 122 I think that's the decimal value of the lowercase characters. And then the uppercase characters are 32 above that, which happens to be hex 20, hex 20, right? Okay. Take another crack, Zach. I do want to hear what you have to say on that. All right. Yeah. So Abby points out, right. So Abby drops this in. So in hex, capital B is 4-2 hex, and lowercase b is 6-2 hex. So if I want to convert a number, so first of all, I got to check to see, is my number in the uppercase range or the lowercase range, right? And I can check that just by saying, is it, above 95 and below 122, or above, whatever. And once I know, and if it's like in the okay range, it's like done. If it's already lowercase, or if you prefer, if it's already uppercase. And so, hang on, this is actually not helping me. Oh, but it's in such pain. Hang on, I got to do one other thing. Sorry. Yeah. What I need is I need the lumbar support. You know what I mean? I need a fancier chair is what I need, or a pillow. Or I could sacrifice Hubert. I can't do it. All right. So if the difference between the expected input and the expected output is some multiple of 32. I'm not sure. I'm not sure. Yeah, that's right. Yeah. So Zach mentioned they could have entered something else. Be really careful of this. The notion, sometimes people will do things like, they'll do like a hash function or something. And you have to understand that whatever you're looking at has to be unique. It has to be like, only works for that one thing. Okay? But anyway, so that's a little bit of noodling. And the other thing we can do, by the way, later on is like a special help section. You know, when you've had a chance to look at it, like next week, where we're just kind of off hours and then we just do another design help section to kind of just answer specific questions and do a little more. I'm still going to get to, there's a couple things I want to draw here. What else? So you have to actually understand also where the inappropriate range is. The inappropriate, you know what I mean? The illegal, unacceptable ranges. So your number has to be like basically between lowercase a and lowercase z, or between uppercase a and uppercase z. And on the ASCII table, there's a bunch of stuff after that, a bunch of stuff in between, and a bunch of stuff before it. And you've got to kind of like march your way through and just kind of go, well, what's my value? And you got to work this logic out. Like, is my value, is my value above capital Z? If it is, that's illegal. Now let me see if it's below. It's almost like you got to like isolate the space. Now it's like, am I below Z but I'm above A? Okay, that's a good range, but it's a capital. So therefore, let me convert it. Now, you got to walk through the logic for the whole thing. Oh, Walter, man, no, I don't know about a tens machine. Let's talk offline, Walter. I want to know about this thing. I've got like the shiatsu back massager, which is wonderful. I got the hot pad, you know what I mean? I got the little roller. That's my problem. I didn't do the roller thing this morning because I had class at 8:30 and I was running late. I usually have a better day when I do the little, you know what I mean? Like the firm noodle that you just kind of like roll your back on. I have that. I got it all, man. So, okay, Zach's still pounding on this 32 thing. Let's roll here. What if you went through each character and checked if the difference was equal to either 32 or 0? Oh, that's interesting. I think I see what you're going after, Zach. The idea that you're kind of exploring is, here's this random, they typed something, right? Maybe it was, capital Z. So, and the only problem I'm seeing so far is, Zach, I think logically that's right, Devin, it's the foam rolling thing. Anyway, Zach, the biggest problem I'm seeing is sort of like, it's really brute force, because I'd have to basically take my character and like compare it to lowercase a, and then check the result to see if it was 0 or 32, then do it for B, and I have to do that 26 times. And that to me feels really complex and might be a pain in the butt to really fully conceptualize. I like the notion of saying, look, is my number bigger? Capital Z has a numeric value. The numeric value is what is in memory, right? You go capital Z, boom, in memory there's a number. Is that number bigger than the ASCII value of capital Z? If it is, it's illegal. If it's not, we're still in the game. So now I'm in this this is also kind of like a state machine, right? It's like a state machine. Because I'm basically saying, I'm starting in the assume it's true. I'm starting in the like tentatively true state, right? Like still going state. And I check to see if the value is above capital Z. If it is, I move to the error state, right? In fact, okay, I just feel like I have a need for whiteboard here. So in essence, I'm going to do, I'm going to call this thing, we'll just call this the start state, okay? Which I'm going to just represent like that. That's our start state. Okay, so Jeanlin, what we're going to do, you're doing this in the LC3 assembler, in the simulator. You write your code as a text file. You name it .asm, and then when you open up in the LC3, you just drag your file over into the LC3, boom. And then you run it, and then it's load, then you assemble and load it. It's really what we did. Or you can actually open it up and paste it. And I can show you as well how to, let me make a note to just, you know, how to do that. But it's really what you should be doing during the homeworks. Just a second. Yeah, I'll go back through that with the simulator. I'm not going to do it right. I'm not going to do it during this one. Or I can also just say, I'll tack that on when we're done. And if anybody wants to stay watching, they can. Otherwise, they can, you know, pause because they got stuff to do and get back to it. Or we can do another, we can just do that as part of the help section. Not sure. I've got the start state, okay? Now, I've got a character, and I'm going to make a comparison. Oh, right, Zach. So we don't know what command. We're just trying to say if it's valid. And so if it's like AND, then we do the thing. So when we're parsing, it's like we go, basically, I'm going to go, okay, remember state machines? I wasn't just dumping that on you for no good. That's an example of start to error. What's the condition? And I'm going to just call the character like C for character. And okay, so it goes like that, right? If C is greater than the capital Z, then we go to the error state. Okay? And otherwise it's below that, right? So I'm going to go to a state that I'm going to call below Z, okay? And so from this state, what I'm going to do is basically go, okay, is C bigger than Z? It's error. C is less than or equal to Z. I'm going to go to the below Z state, okay? It sort of just says I'm staying alive. Now my question is, am I, from that state, I know I'm somewhere below here in the ASCII table. Now I'm going to be like, okay, am I above the uppercase A, right? If I'm above it, then I am in then I'm in uppercase land, right? So let me see. Trying to make this fit on the page. Okay. So, okay. And by the way, you know, you can also like screen grab on this thing, okay? What this is doing now, it basically says, if I can, where am I? Got to get like this. I'm in the below Z. If my character is greater than capital A, then I have an uppercase letter. I'm in this state now. And if it's below that, then I'm, you know, C is less than the capital A. I'm in the state that I'm calling below A, which means that I'm now at this point in the ASCII table. Next is going to be a bunch of junk. And then next is going to be lowercase z. Okay? So at this point, I'm going to ask the next question, which is, am I bigger than lowercase z? Okay? If it's bigger than lowercase z, hang on, I'm going to do this. If it's bigger than lowercase z, it's an error. Okay. Okay, I tried to draw that right here. Okay, if sorry, if it's bigger than lowercase z, oops, I can't do this. I'm doing this thing mirror image. Then that's an error, right? So in other words, I'm checking to see, am I above capital Z? No. Okay, then I'm below capital Z. Okay, am I above capital A? Yes. Okay, then I'm an uppercase letter. No. Okay, I'm in the below capital, capital A. Am I above capital lowercase z? I'm in that junk zone between the caps and the lowercase in the ASCII table, right? And so if it's less than or equal, let me see. Wait, hang on. If we're greater than z, we go to error. Oh, the question is now, am I greater than or equal to the lowercase a right? Okay, and so that is like, if it's above that, I'm in the junk zone. If it's also greater than, so you get the part where to get here, sorry, it's so hard to do this mirror image. To get here, I have to be below I got to be below, what am I doing? Hang on. I lost my mind all of a sudden. I'm below the Z. Oh, I'm below the A. If I'm below the A, but I'm also above lowercase z, I'm in error. So therefore I'm below lowercase z, but if I'm above or equal to lowercase a, I'm a lowercase letter. And then from this part here, what happens? Yeah, I'm in lowercase. These are terminal, by the way. It's like, I'm done. So if I'm greater than lowercase z, I'm not that. Anyway, I may have actually I'm trying to do this real time pointing backwards. I think this is not super clean, but I'm trying to just express the logic. You can also express it as a series of if then else statements in like a high level line. But you get the idea. I can view it as a state machine. I can also go something like this. If C is greater than and I'm just going to do this. I'm going to use this as just errors or like a go-to. It's mythical language, okay? So what I'm doing is I'm like, okay, if the character is greater than capital Z, go to error. Jump to error. JSR error. Or, you know what I mean? Go to where you handle that error. So that's what go to error means. And then, basically, you're jumping out of there. So if you're still alive, it means that it's like an else statement, but really, that didn't go. And so you're now just, you know that it's not. It's less than or equal to Z by definition. So now if C is greater than or equal to capital A, okay? If it's greater than or equal to capital A, then I'm going to go to uppercase. That's my routine. I could be a JSR, I could be jumping, but I'm going to the routine that handles the uppercase. Okay? Well, if I'm still here, if that was the case, I teleported away. I didn't teleport, so we must be in the space, right, below that capital A. Now it's like, so if C is greater than little z, okay? If C is greater than little z, I go to error. If that didn't happen, I'm still alive, means I'm lower than little z. If C is greater than or equal to little a, go to, okay? If C is greater than or equal to little a, I go to lowercase, which is my routine, my little routine I built, right? And guess what? If I'm still alive at that point, I just go to error. Okay? Let me hold this up. You guys can you can screen grab it. This is just some of the logic, okay? Of what you're trying to do to tell whether something's uppercase or lowercase. Okay? Everybody tracking? You got any questions about that? And I'm going to jump over, use my other hand. Let me see. I think I answered Jean-Lynn's question. You guys got any questions about this? This is the logic, which means that in your assembly, you got to work that comparison. Take the first character that they entered and run this comparison. And if it's bigger, you know how to do comparisons, right? And you know how to branch on conditions. Yes, you do. If it's over Z, you're in the error zone. And this is the weird logic, okay? You realize that it's like, let me do this as well. Let me just draw you one more picture. Let me see. Okay, this is a representation of the ASCII table. Beautiful, right? Okay, now check this out. In fact, I'm going to throw this up there because we just did, hang on a second. I had these up previously, but yeah, let me pull up this ASCII table just to make it really clear to you guys what we're talking about. But that's the ASCII table. Oh, let me stretch it. Come on. Okay. Okay. And I know this is a little rough to see because it's just scanned, okay? Here's what you can see. Oh, sorry. I'm such a dumb. This guy here, I did it wrong. It's lower Z, lower A, capital Z, capital A. Was I confusing anybody who was already knew what that was? Hang on. I'm error correcting here. I even made this sort of Python-like for your entertainment. Okay, sorry. But again, this is why, the logic is still correct. I'm just looking at this thing going, okay, let's remind ourselves, shall we? These are the big numbers, and here comes, so what you're really saying is, if the character is bigger than 122, is another way of saying that, okay? Then it's one of these. Right? So I'm just going to represent that with just, that's junk right there. Blah, blah, blah. I don't care. Then here, and then in this zone of the ASCII table is where the lowercase letters are. There we go. That's where the lowercase letters are. Okay? And then below that, Christmas colors all around, more junk. Then comes this is beautiful, man. Okay, so do you see what's going down? So what I'm saying is, if the number value is above, up here, error, quit. Okay. It's not, so I'm still alive. if it's greater than or equal to here, then I know I'm in this range. Boom, uppercase. Okay, wait, sorry. Okay, hang on. Okay, sorry, man. This is it works. You understand what I'm doing, right? So if it's in that range, it's a lowercase letter. You go to the routine that handles that. Otherwise, if you're above the Z, and you realize that if you had been up here, you already teleported away, right? You're still alive, which means you're not above there. You're here or you're below here. So am I above here? Yes. Boom, teleport to error. Or I'm not. Therefore, I'm down here, somewhere down here. Am I above the capital A? If I am, boom, I got an uppercase letter. If I don't, I've got an error. Everybody got it? Screenshot. And no, I am not going to post this thing. I'm not going to post this on Canvas. It's right here. And, you know, hopefully this was making some sense. Okay, that's an example of just kind of algorithmically helping you along with this process of just converting an uppercase to a lowercase. Now, what I didn't do is actually do the conversion. When you go, let's say we're going to convert everything to lowercase, right? In the lowercase is where I'm actually doing whatever. Let's say we're converting to lowercase. Let's say the lowercase subroutine does whatever it is I'm going to do. The uppercase, that, you know, with a character that's legitimate, when I've got an uppercase, what I'll do is call that routine, and this one will convert it. And how am I going to convert it? We already talked about this, right? How am I going to convert that uppercase letter to a lowercase letter? I'm going to add hex 20 to it, right? Which is actually Abby, I think, already said that. Okay? Everybody good? I mean, is this making sense? Got a lot of long silence. Either it's like dazzling or I stopped broadcasting. Are we still good? Everybody, especially the Discord people where there's no latency on the audio. Anybody with me? Okay, all good, all good. I just wanted to make sure that I wasn't, you know, technical difficulty. Okay. But what I would do with the uppercase is I would add 20 to it. That just converts it to an uppercase letter. If it's already a lowercase letter, I can add 20, hex 20, and it'll convert it into an uppercase letter. Then you know what I would do at that point? I would then go to lowercase. So in other words, it's like lowercase goes straight to the part where we're going to deal with it. Uppercase goes over here, gets converted to lowercase, and then goes to the same spot. Okay. Now, what we have not done, still fearful. By the way, I want to just say one thing. We're about out of time. Maybe we need to, still have other material. We can do a help section to talk more about the project. But I do want to talk about the state machine with everybody. The state machine idea to this thing. I do. So let's do that on, what is today, Thursday. We'll do that on Tuesday, but I'm going to reserve the right to do a little help section or some other sections that you can hit on your own. If for any reason we run out of class periods, the delay and everything really did introduce some struggles. But what did I want to say? When you build this thing, you could start right now just working on this code, right? In other words, just like you enter a character and your program just tells you, was that character an error, an uppercase, or a lowercase? You can write that program like right now. You already have the skills. Through Module 8, you have all the skills you need to write that program, okay? You got to poke around just a little bit more with the keyboard stuff, which we got to hit. But even then, it's not. You look at the trap routines, and it's not that hard. Then what you do is you get that working, and it's like, okay, now I can flesh out what I do, you know. But what I want you to try to do as you build this thing is build. Don't try to just sit down and write all the code down, 600 instructions, and then say go. You're doomed. You're doomed if you do that. Okay, it will not work. Not for me. Not for you. Not for anybody. Okay. What I want you to do is build a chunk, test that chunk, make sure that you know that that chunk works. If you're entering a string and you're putting it in memory, then enter the string, stop your program, and go look in memory. Or put it in memory, null terminate it, and then call the put s routine to spit it out. I mean, know that it works, then do the next step. Okay? Know that it works before you go on to the next step. That's the fundamental idea. Okay? And then the other thing I was just going to tell you, and I'll try to bring this up again since we're on the tail end here today. But I just want to say, how long is this going to take you? The quickest really about ever tends to be about 5 or 6 hours. Okay. When I finally did it myself, I did it in one all-nighter. Sleep's overrated, right? And I did it between like 1 a.m. and 7 a.m. So it was like 6 straight hours, you know, without a break, you know. And that's about as quick as it ever gets, really, you know, maybe a little quicker. You know, on the upper bound, people that are going to struggle a lot more might spend 20 hours. Could be worse than that, possibly. If it is taking you 20 hours, I would say you may want to pull back and be thinking about your design. You may have a bad design. You may be exercising some really bad programming practices, like just start changing crap and hoping that it'll work now. If you are doing that, you got to get a hold of me or Devin or Talmadge, okay? If you're changing an instruction hoping that now it's going to work, you're really, really hosed. So you got to stop, because you can't be guessing and hoping that this will now make it work. You can't do that. You're not going to win. You got to know what you're doing and why you're doing it, which means you got to know what the instructions mean, what they really are saying, how they actually work, okay? Okay, so, but we are available for that kind of discussion. And I think that's probably good for now. This hopefully helps. One more time for screenshot if you want to grab it. And then one more time for this if you want to just look at that down the stretch. I keep this here for like Skype meetings, because sometimes that just comes in handy. So yeah, ping me. But man, you gotta get caught up on the modules. Seriously, the numbers are not good right now. And I'll work with you, but you got to do your thing and check in with us, okay? All right. Any other questions, hit me up. I'll be on Discord. And if you have like general questions, you want to just dump them to the general Discord channel, and then other people can read it as well. So, okay, my amigos, good luck. Stay safe. Did anybody check out my QR code? Just curious. I was experimenting with layout on the OBS stream broadcast. Things I can drop in, graphics that I can decorate it with. Okay, Devin, all aboard the struggle bus. Everybody on board. We're going there together. That's the thing. We are going there together. I will help you. Devin will help you. Talmadge will help you. We are going to get through this thing. All right, man. Take care. I'm gonna just hang out for a second so that we get any just last comments on the YouTube channel. We'll set. Let me see. There we go. Yeah, we're just gonna go like that down the stretch. Are we good with that? Yeah, okay. Alrighty. Okay, I'll see everybody on Tuesday. Good luck. Tanner, I am never going to let you down, man. I'm just telling you. Okay, guys. All right, I'm dialing out.